Example 8.11. Consider the function f of x, which is 5xy divided by x squared plus y squared. Let's evaluate this function as we travel towards the origin along straight lines, and then use this to justify that there's a discontinuity there. So remember, in multiple, or in fact, in one dimension, a function is going to experience a discontinuity if either the limit does not exist, or maybe the limit exists, but does not equal to your function. Right? Here we have the exact same idea. So if I take this function f of x, and I want to show that there's a discontinuity at the origin. In fact, we can show that that's going to be the only possible place where a discontinuity can happen, because where's the only possible place where this function might not exist? It's when x and y are 0, right? Then you divide by 0. But as long as x and y are not 0, then this function is going to be just fine. So what happens as we travel towards the origin? Let's show that in fact, the limit is not even going to exist. So therefore, there's no way it's going to be continuous. And let's show that the limit does not exist by finding two different limits depending on the path that we travel. So let's take the limit as xy approach the origin. And it says to specify that I should travel along straight lines. Right? So if there's my origin, there's x, there's y, here's the origin. Then traveling along straight lines is you traveling along y is equal to mx plus b's, but the b has to be 0 because you want to hit the origin. So let's travel along lines that look like x, and the y value is some multiple of x. All right, so here's our function, and let's go after it. So if I can replace my y's with mx, i.e. I'm traveling along this function along straight lines, then my function is going to be 5x times mx, right? Replacing that y with mx over x squared plus m squared x squared, replacing that y with mx. All right, let's clean this up with some algebra. This is going to be 5mx squared over x squared times a 1 plus m squared. Or 5m over 1 plus m squared. So we're done. And what's important is that we recognize why we're done. Depending on the m value, so depending on which straight line I travel towards the origin along, I'm going to get a different limit, right? If I travel along the line y is equal to x, so the m is equal to 1, this limit is going to return a 5 over a 2, or a 2.5. But if I travel along the line y is equal to, I don't know, let's say 2x, then this limit is going to return a 10 over a 1 plus 4, or a 2. Right, so depending on how I travel towards the origin, this function is going to give me different limits. Therefore, the limit is not well defined. The limit does not exist. The function cannot be continuous.